Now we saw in the last video that we could solve 3 sine x equals cosine x. Here is a harder version of it. In this problem, the reason why it's harder is because we have this constant that's being added or subtracted to the sine or cosine. There are a couple standard ways to go about it, and I will show you one. What is the issue here is that we can't just divide by cosine like we did before, because now we'll have 1 over cosine, so we'll have a secant and a tangent, and that's not very helpful, and then we still have a constant. So what we can do here is we can see, is there a relationship between sine and cosine? Well, we know there is for sine squared plus cosine squared equals 1. Is there, and is that what we have? No, it's not. But can we create that? Yes, we can. So we can say 1 minus sine x, and we can square that as well as squaring the other side. So we'll get 1 minus 2 sine x plus sine squared of x equals 9 times cosine squared of x. Now, recall we have our identity of sine squared x plus cosine squared x equals 1. If we divide by, actually we don't want to divide, sorry, we want to solve this for cosine squared, so cosine squared x equals 1 minus sine squared x. Now how do I know that's the one I want to solve for? Because when I'm looking at this equation, I have sine squared, cosine squared, so that's flip of the coin, but I have a sine x. Because of that linear factor, sine x, it's a first degree, that's going to dictate I need to get everything in terms of sine, since this is a quadratic equation, a quadratic form. So now I'll do my substitution, 1 minus sine squared of x, and multiply that out. And I should just go ahead and rewrite this. Now I want to solve my quadratic equation. I'm going to move the sine squared to the left side. I'll move everything to the left. So when I add 9 sine squared x, I will get 10 sine squared of x. And I'll have minus 2 sine x. And I subtract 9 from both sides, so 1 minus 9 will give us 8 equals 0. One thing I can do is I can divide everything by 2 to make my numbers a little bit smaller. It's not essential, but it helps. Now if I notice here, 5 and negative 4, if I add those together, I get a positive 1. What that tells me is I can factor this pretty easily. I know that the factors of 5 are 5 and 1, so it's going to be 5 sine x and sine x. Now, when I have the first and the last added together to give me the coefficient of the middle term, and I'm not looking at the sign there, the SIGN, the positive negative, that says they're basically going to be in my one set of parentheses because they have to be added together so they cannot be multiplied together. So that means the 4 will be here and the 1 will be there. Now I want to make it a negative in the middle, so that means the 5 will have to be negative, which forces this 1 to be negative, and this is positive. So now we'll have sine x equals negative 4/5, or sine x equals negative 1. And what do we do now? That's right, unit circle. So when I draw my unit circle, I have sine x equals 1. Sine is our y value. So y equals 1 gives us that solution right there. X is pi over 2. Oh, I didn't write it on this one. This would also be from 0 to pi over 2. Sine x equals negative 4/5. Here's negative 1. 4/5 would be a little less than that. And we're going to get 2 answers. Now, is negative 4/5 a unit circle value? No, it is not. Remember, our unit circle values are 0, 1/2, root 2 over 2, root 3 over 2, and 1. and then the negatives of those. So what we need is our calculator. So we're going to turn this on, and we can say second sine or inverse sine of -4/5, -4 divided by 5. Hit enter, and it gives us x approximately equals to -0.93. Now, how do we find the other one? What we're going to need to do here, and just to go over the idea, I tend to want to store a lot, and so the store button, let me see if I can move this up so you can see it. There we go. This store button is right above the on key. You press that and it says answer arrow. Now what you do is you tell it where you want to store that value. So let's press alpha and then A. And when I hit enter, it just repeats the number, but it means that it has been stored in that spot. So I know this one's in A. And now how do I find this second value? This value is 0.93 and going in the down direction, the clockwise direction. I want to go all the way around to get to there. Well, there's a couple ways we can do it. We can realize that this is half a circle, and this is going to be 0.93, so we could say pi plus 0.93, which is the same thing as saying pi minus the answer we had over here of -0.93. So on our calculator, we could just type that in, go second pi minus second the negative symbol, answer to bring that up, and what does that give us? 4.06. So 4.068 will round to 4.7. Let's store that, STO, alpha. I'm going to put it in D, and the only reason I'm putting it in D is because that's right below it. So just as a reminder, I'm going to put a little think box here, and there's the letter D. Now, is -0.93 in our domain from 0 to 2? No, it's not. How do we find the answer between 0 to 2? We're going to have to find a coterminal angle with it, so we will add 2 pi to that. On our calculator, we can say 2 pi, oh, did the wrong one, 2 pi plus, now where did we put that -0.93? That was in A, so we can say alpha A. And we get 5.36 when rounded. Are we done? No. Oh, I should store this as well. We'll say store alpha B. So I'm putting this one in B. Why are we not done yet? Because let's go back to what we did at the beginning. We squared both sides. What happens when you square both sides? You have the possibility of introducing extraneous solutions, extra solutions, solutions that don't work in the original one, but that will work after you square it. What kind of things are those? That would be if you have a positive or negative squared, let's say +2 and -2. When you square it, you get the exact same value. So that is an extra solution if that occurred. Let's take a look. So what we need to do is check. You always need to check if you square both sides. So we'll say 1 minus sine of 5.36. Does this equal 3 cosine of 5.36? Now we're not going to really use 5.36. We've stored that into B, and that's what we're going to use. So on your calculator, you press 1 minus sine, and we have that in B, so we'll type sine alpha B. Press enter. That gives us 1.8, so let's just write 1.8 equals, let's type in now 3 cosine of alpha B. Enter. That equals 1.8, so that is a solution. Let's check the next one. 1 minus sine of 4.07. Does this equal 3 times the cosine of 4.07? Recall we have that in D now, so we can say 1 minus sine alpha D, and that gives us 1.8 again, and 3 cosine of alpha d, and that gives us negative 1.8. So that is not a solution. And we have one last one to check. 1 minus the sine of pi over 2, does this equal 3 times the cosine of pi over 2? And since you know your unit circle values, you don't need a calculator for that. That's 1 minus 1 equals 3 times 0. So 0 equals 0, and that checks out. So that means our solution set for this problem will be 5.36 as well as pi over 2. And that is all.